Hi learners, welcome to our channel. We are doing mathematics paper 2 from question 5. Let's dive into it. Given that cos B is equals to minus 1 over root 5. So how do you approach these ones? You make a Cartesian plane. Make a Cartesian plane. Cartesian plane is like this. So where is cos minus? Cos is minus in a second quadrant and in a third quadrant. And then where theta is between 180 and 360. So 180 is here. From 180 to 360. So 180 and 360. Meaning our diagram will be here. Right? Okay. Let's go ahead and do it. Determine which, with the aid of a diagram, the value, with the aid of that, without the use of calculator, the value of sine beta. So we are given cos beta is equals to minus 1 over root 5. So our diagram is going to be here as stated, right? So this one is minus 1 and then this is root 5. So we have witnessed this formula before. Okay, the beta is here, or you can just in your mind focus on this triangle only. Okay, it's supposed to be a right angle triangle anyway. Okay, r squared equals to x squared, or no, x squared plus y squared. What is r squared? Is 5 equals to 1. X squared is equals plus y squared. And you transpose, it's going to be 5 minus 1. 4 equals to y squared, and then y equals to square root, you square both sides. Square root of y squared is y. Square root of 4 is plus or minus 2. Plus or minus 2. So you look at the y values, then our answer is going to be minus 2. But you are looking for the value of sine beta. However, sine beta equals to opposite over hypotenuse. You don't have to stress much, and beta is opposite over hypotenuse, which is minus 2 over root 5. Okay, add sine beta, and the next question, determine the value of the following expression. Let me write the expression so that we solve. Ten 180 minus x, and then sine x minus 90 all over 4 sine 360 plus x, 4 sine 360 plus x. You are required to do what? To simplify. Okay. 180 minus. Where is 180 minus? 180 minus is in the second quadrant. So 10 is negative there. Minus 10x. Okay. Sum for this one, they plus 360, or sum they just do like this. They took out the common factor, which is minus, and then when you took out the common factor of minus, you're going to have 90 minus x. You see? And then 360 plus is in the first quadrant, so here we're still going to have 4 sine x. So all negative angles are in the fourth quadrant. All negative angles are where? Are in the fourth quadrant. Okay. Maybe we'll change in the next step. Equals to minus 10x. All negative angles are in the fourth quadrant. So it's going to be minus sine x. Minus sine x, and then with this 90 minus. So sine changes to be cos. So it's going to be minus cos x. Right? Good. Then let's write this guy now. Things look much better now. 4 sine x. You see? This negative multiplied by negative is going to be positive. These things multiply each other. And then you know that 10 can be written as sine x over cos x multiplied by cos x. This is the cos x. We change this 10 to be sine over cos. Then all over 4 sine x. This one cancel this one. You are now left with this guy. You are left with sine x over 4 sine x. You know what's happening? This one cancel this one. And then our final answer is going to be 1 over 4. Okay. And let's check the next question. When they did not give you a constraint, you take this thing and put it in the first quadrant. Okay? Sine A is equals to P. Cos A is equals to Q. Determine the value of tan A. Tan A is equals to sine A over cos A. Then this is easy. Sin A over cos A. What is sin A? P cos A is Q. Those were 3 marks. The examiner was generous. Okay. Simplify P to the power 4 minus Q to the power 4 to a single geometric ratio. Okay, let's do it. You have to simplify. P to the power 4 minus what? Q to the power 4. But this one is a difference of 2 square. Right? Yes. Which is P to the power 2 minus Q to the power 2. P to the power 2 plus Q to the power 2. Okay, this is the difference of 2 squares. And then we can proceed, from the original statements that we go back, that sine A is equals to P, cos A equals to Q. So whenever we see sine A, we put a P, or whenever we see a P, we put sine A. So the solution thereof is equals to P squared, which is sine A squared A, minus what is Q squared minus cos squared A. Oh no, squared A, right? Okay, I ran out of space. Multiply. You have to write this thing here. Let me write it here. Multiply by P squared. What is P squared? Sine squared A plus cos squared A. This one is this, okay? However, sine squared multiplied by cos squared, it is 1. And this one, this guy is equals to a double angle, which is this is going to be a double angle, which is going to be minus cos 2a, and this one is going to be a 1. You see? Okay, and we are solving the next question. What are they looking for? Consider this identity. Prove the identity. Prove that the left hand side is equal to the right hand side. Prove that the left hand side is equal to the right hand side. You are given this guy. Cos theta over sine theta minus cos 2 theta over sine theta cos theta. So this is our right hand side. Okay, it should give you 10 theta. How can we go about solving this one? Let's make this one a single fraction. I think that's going to simplify our lives. The common denominator, it is sine theta cos theta. Not the common denominator, LCM. Sine into this sine cancel, and you are left with cos, and the cos that you are left with multiplied by this one, you are having cos squared theta minus this one in this one into this one. It's a 1. 1 multiplied by this is cos 2 theta. So the cos 2 theta is a compound angle. We have to fix it. So next step, you can just write like this: cos squared theta. We expand this one, cos squared theta minus sine squared theta, and then I was supposed to factor out the negative already. Come on, you are in grade 12 of the hour. Okay, you see something interesting here. This guy will minus this one, and then you are going to be left with what are you going to be left with? This minus times minus is going to be positive sine squared theta all over sine theta cos theta. Okay, then you have the sine top minus bottom. You see, you are having now sine theta over cos theta. What is this thing equals to? Equals to 10 theta. Then you conclude, therefore, right hand side equals to left hand side. All right. Then, for which values of S is theta in the interval 0 to 180 will be undefined. Undefined, it means that there won't be any solution. Will be undefined. So undefined, since our solution was 10 theta, meaning we can focus on the denominator, sine theta over cos theta. So undefined should be this guy equals to 0, so that this is giving me error. Cos theta equals to 0, right? And then you solve. Let's try it. And then when it's cos theta equals to 0, you are solving for theta. Theta is equals to 90 degrees. Right? Okay, and then also you have to consider this part. You see, if you have over 0 here, it's going to be undefined. So you can go further and say okay, theta is equals to 90 degrees. It's your 90. Congratulations. Right, then you can just say again, sine theta must also be equals to 0, because when you're having a denominator of 0, you are getting an error from this original. So yeah, and then sine theta equals to 0, then theta equals to 0. So we got the values, and then 5.5 for which values. Okay, 5.5, determine the general solution. Oh, this is beautiful. 2 sine 2x plus 3 sine x. Let's do it. 2 sine 2x plus 3 sine x minus 0. Or we can say equals to 0. Okay, we go ahead and expand this double angle here to sine x cos x plus 3 sine x equals to 0. So the sine x is common to both of these things. So sine x, open bracket, what is left is this 2 cos and this 3, which is 2 cos x plus 3 equals to 0. Okay, and then you can just say sine x is equals to 0, right? Or cos x is equals to minus 3 over 2. Hopefully you are not lost there. We're looking for the general solution. We start with this one. Pardon me guys, I'm a bit sleepy as I'm doing this video. So the reference angle here is going to be 0, and then first quadrant x is equals to 0 plus k 360. You see? And then that's our solution. And then what else? Yeah, that's it. And then from here you can find the reference angle, the ref angle first, the ref angle. After finding the ref angle, you check where is cos negative. When you are saying 180 minus the ref angle, you are going to get this guy, 180 minus the ref angle. You are going to get x is equals to 138.59 plus k 360. But whenever you're saying 180 plus, why 180 plus? Because cos is negative. 180 plus the ref angle, which is 221.41 plus k 360. Don't forget to mention that k is an element of integers, where k is an element of integers. In both, k is an element of integers. Okay, what's the next question? Let's see. Okay, we're done with this one. Let's move to the next question. trigonometric functions. The diagram below, the graphs of f of x equals to sine b x and g of x equals to minus cos x are drawn from this constraint. Use the diagram to show that to answer the following questions. So write down the period of f. Let's look at f. So f is this. F is this. Look at the complete cycle of f. You see, that's the complete cycle of f. So what is that complete cycle? Because it's right in front of us. This one is 60, this one is 60. So the period is 180. Determine the value of b. Let's see, where is b? The b is with the sign, like this is b. So the easier way to do it, k is the factor that affects period. So period is equals to 360 over k, in our case, over b. Then you substitute. You said period is 120, which is equals to what? 360 over b. So you cross multiply. B 120 is equals to 360 divided by 120 both side. Divide by 120 both side. And then you divide by 180 both side. You find that B is equals to what? 3. So now you found 3. And then the next question, okay, you're looking for the general solution of the equation sine b minus cos x and x. So when these things, you are looking for this value and this value and this value. This is where these two functions are equal, right? So you are going to solve for these values where these two functions are equal, right? Let's see if you solve and find that they are equal at x is equals to 45. They are equal at x is equals to 22.5. They are also equal at x is equals to 67. You will solve it. Tell me if you got it right. X, you equate these equations, you solve for x. So x is an element of, they are equal at minus 45. They are equal at minus 22.5, right? And also they are equal also at 67.5. Yeah. and 67.5. Okay, and 290. Okay, then write down the values for which. Okay, we're done with this question. Question 6, we're done. Hopefully you are understanding the question. And now doing question 7, proportionalities or similarities. I don't know, what do you see? Okay. Question 7. You are given these things here. Triangle PQS forms a certain area of the park. R is a point on PS. So, PS that divides the area of the park into two triangles as shown. PQ is equals to PR as shown. This is an isosceles triangle. You see this isosceles triangle. Okay. And then RS is this, and RQ is what? RQ is root 3x units, right? Calculate the size of calculate the value of P. How can we go about? How can we go about? We know QR, and then what is P? Angle P. We can use cosine rule. We have a side and a side. We are looking for the middle angle, right? Let me just write it underneath. QR squared, it's a cosine rule, is equals to side PQ squared plus side PR squared, right? Minus 2 side and middle angle, 2 PQ PR and cos P. It's not over cos P, it's n cos P. So you just put the value now. This one is root 3 to the power 2. It is x squared plus x squared minus 2x cos P. Right? Then you manipulate and maneuver. This one is going to be 3x squared. This one is just going to be 2x squared. And then minus 2x squared cos P. Okay. And then this x squared, this x, what's this thing? This one is common. You see? So you are taking it out. 3x squared is equals to x squared into 1 minus cos p. Right, these ones you divide both sides by 2x squared. You are now left with 3 over 2, which is equals to 1 minus cos p. Right, and then this looks good for me. Transpose the cos p to the other side. Cos p is equals to, transpose the 3 over 2 to the other side. 1 minus 3 over 2. It's going to be minus 1 over 2. So when it's minus 1 over 2, then you do the sign inverse. Therefore, p is equals to 120. That's it. Okay, let's go to the next question. Hence, or otherwise, calculate the area. Hence, use the previous answer. Hence, in terms of x, area is like cosine rule. It's half, side, middle angle. So, area is equals to half. Side is PQ. Side PR. And then sine middle angle, which is angle P. Then you substitute the values and which area we're looking for. Area of QRS. QRS. Okay, that was the formula for the small area. That was the formula for the small area, which is QPS. You can calculate the area for the larger thing, or you can calculate the angle that is here, right? And then let's get that angle. When you get this angle, here it's going to be 120, and then here it's going to be 30, and then here it's going to be 30, right? And then here it's going to be 150. So the area is now going to be this one, QRS. We're focusing on this one. Sorry for not focusing on the proper area. So what do we do here? We are calculating the area. We are calculating the area. We are going to say A is equals to half QR multiplied by RS multiplied by sine theta, which is P, which is R. And we substitute. When you substitute, we have half QR is root 3x. RS is what? RS is 3 over 2x. Is 3 over 2x. And then sine theta, which is sine 150. Don't be scared of these things. So in order for you to master such questions, you have to focus on the sine rule and all that. So when you multiply sine rule and area rules and cosine rules, you have to know those easy things. And yeah. So whenever you multiply everything, 2 times this and wara times 2 times 2, I don't have a calculator. Let me just do this, 3 root 3 all over 4, and there's an x. And x times x, which is x squared, sine 150. I think it's sine 150, papa. It's in the second quadrant. Sine is positive there. You see that? And then, therefore, the area this times this, it is 8. So our area, therefore, A is equals to 3 root 3 x squared over 8. Okay. Let's move to this question. They want me for question 8, 9, 10, 11. That's Euclid then for you, my child. Okay. In question 8, in the diagram, ACD is drawn with points A and B, and the circumference of a circle CD cuts circle at B. P is what? P is a point. You can see P is a point AD. On AD, you would see P, the bisector of ACD. The bisector, when something bisector of ACD, meaning this is also 25. Which one? AD, CP is a bisector of ACD, so 25, 25. Okay, and then it cuts the chord. Okay, this one is easy. 80 and 80 is equals to AP. 80P is 65. As you can see, PCD is 25. So let's go ahead and solve the problem. Calculate the sizes of P2. They need reasons here. P2 is simple. This is an isosceles triangle. P2 is 65. You see that? Why is P2 65? Isosceles triangle, the reason for isosceles triangle, let me just write here. Why is it 65? Angles opposite equal sides. Angle opposite equal sides. Let's look at D. They say this guy is a diameter. They mention about this thing being a diameter. Okay, we are looking at D. Where is D? Where is D? Circle. There's another circle. There's another circle here. Cast the circle CD. CD. The circle HP. You see? It's the only circumference of a circle CD. Okay, and then let's do this one. I'm trying to work everything that we can get. This one is 65. This one is 65. Trying to get information, guys. What else? So why is that 165? Vertically opposite, right? Where can we go from here? How about A2? Can we find A2? When you say 180 minus 65 minus 65. What is 180, guys? 180. Oh, sorry, what is A2? You can say A2 is 50. Right? And then you can find B1. You see? Why A2 is 50? Sum of angles of a triangle. You write the reason you are a student. And then you can also find this B1 when you're just saying 180 minus 25 and minus the 65 as well. You should get maybe, I think this one is 90. So if this one is 90, this one is also 90. So now we can easily find D. You can just say sum of angles of a triangle. So yeah. So 180 minus 50 minus 90. You see? What do you get? You get that this thing is 40. I gave you the reason already. Sum of angles in a triangle. D equals to 40. Just keep on finding these things. Sum of angles in a triangle. But you write all the reasons that helps you to get there. How about A1? Where's A1? A1. I'm looking for A1. A1 is this one. A1 is this guy. So this looks good. You can find T, right? After finding T, what is T? Which is 180 minus 65. So it's 40, right? Let me show you something. And then this guy is a tangent. CA is a tangent. When CA is a tangent, let me erase here. CA is a tangent. You see? And then here you have a triangle inside this circle. Draw nicely. You have a triangle. Right? You see? Measure, skip, mark. Meaning A1 is equals to D, which is equals to 40. The reason behind that is 10 chord theorem. It's 10 chord theorem. Okay, you understood? Moving to question 9. We are almost there. Question 9, in the diagram, O is the center. Of the circle, BO BO and OD are drawn. These are radius, and then chords EB and DE are produced. Okay. Are produced to meet A. Okay. Chords BE and CD are drawn. BCD equals to X. Give reasons each of the following statements in the table. They provided the answer. Okay. Y is A1 minus X, or A1 is equals to X. It is simple. A1 is equals to X. Why is it like that? Let me show you something. You have this one, this one, this one, right? And then let me make a long straight line, right? This is X, and this one is also X. Measure, skip, mark. So what is this one? It's an exterior angle of a cyclic quad. You just write the reason. The reason this is like that, it's an exterior angle of a cyclic quad, of cyclic quadrilateral. You're gonna remember that in an exam. And then O1 is equal to 2x. Let me draw this thing so that you see it. This is like this. Let me adjust it nicely. So that you see it. Come on. I want to make a nice line, guys, so that you don't blame the bad drawing of mine. Okay, this is like that. Yeah. Angle at the center. Oh no. Angle at the center is 2 times the angle at the origin. You see that? Angle at the center is 2 times the angle at the circumference. Angle at the center is equals to 2 times angle at the circumference. You write in full So you saw this is this condition, the highlighted red is this condition, okay? It is given that BE is parallel to CD. BE is parallel to CD. So they told us that these two lines are parallel. What are you required to prove? Prove that AC is equals to AD. How can you go about? You can easily say, let's look at the diagram. Let's just get CDA. CDA is equals to what? Is equals to angle E1 equals to X. Y, it's corresponding. I'll show you corresponding angle. Look at this one. If it's parallel, you are having this one. You see there's an F. Oops. Let me show it here. You see there's an F. Oh no. Okay. It's fine. It's fine. There's an F, guys. So if this one is X, this one is X as well. There's an F corresponding angle. Okay, then CDA is equals to C, which is equals to X. Look at this one. This CDA is equals to C. So there's an X here, there's an X here. What is that supposed to tell you? CDA is equals to C is equals to X. So it means that AD, this means that AD is equals to AC, right? Hopefully you will understand. Prove that ABOD is a cyclic quadrilateral. Okay. Let's check. Which one is a cyclic quadrilateral? ABOD. ABOD. Let's check ABOD. Let me remove everything. ABOD. So ABO. Come on. ABOD. So here it's X, right? And then here is what? One at the center. Here is 2X. And then which one can we use? We can get this one A using this triangle, right? If here you are having X, this small, and then here you're having x. So a is equals to 180 minus 2x, right? 180 minus 2x, but when you're adding this one and this one, it's going to be 2x plus 180 minus 2x, which is equals to 180. That makes this thing a cyclic a side quadrilateral. Therefore, ABOD is a cyclic quadrilateral. Is cyclic quad. Why? This thing is opposite angles of cyclic quad. Even if you will get it right. Then we are almost there, guys. We're almost there. We're now doing question 10. Before we do question 10, we start with question 11. Then we will do question 10. Question 11 is the last paper of the thing. Question 11. What are they saying here? Oh, we're now in 11.2. You have to start in 11.1. 11.1. Why am I taking question 11? Because it is something similar to what we're just doing now. Okay, in the diagram, O is the center of the circle. PA is a tangent to the circle at A. B and C are points on the circumference of the circle. Okay, this is the diagram. Use the diagram to prove that BAP, this angle is equals to ACB. Because to this angle, we are proving the 10-chord theorem. So how can we go about? So we can do DCA, or we can construct. Let's construct. When you construct, construct this line, right? And then after constructing, what can we do with our construction? So we notice that OA is equals to OB. The reason is radii. You write the reason. Radii. Okay. After that, this will tell us that OAB, you see OAB and BAP. Let me show you. OAB. Let me use this thing. OAB plus this one. OAB plus BAP is equals to 90. Do you understand that? And then BAP is equals to 90 minus OAB, right? Okay. How can we find this other one? OAB, you see OAB is equals to OBA. OAB is equals to OBA. So this one is equals to this one. OAB is equals to OBA. Do you understand? You have to write the reason equal, or you can say opposite equal side. Angles opposite equal sides, right? Or equal sides opposite angle, right? And AOB, where is AOB? AOB is equals to 2 times what's this thing? But okay, before we get there, you can just say AOB this one, AOB is equals to 2 times, okay, maybe you can say 180 minus 2 times, what's this thing? OAB, right? And then you take out the common factor, which is, no, you don't have to take the common factor. Let's look at C, angle C, which is sum of angles in a triangle, the AOB. Angle C, CB is equals to half of this one, which is 90 minus OAB. You see, this one is the same as this one. Why do we say that? The reason angle at the center equals to twice the angle at the circumference, right? I think you guys are following. Then let's continue. In the diagram, C is the center, and then GAP, BA is the tangent, okay? Okay, guys, this is the question, right? This is the question, and it's out of 150. In short, and comment your answers in the comment section. We are going to do it in our next video. We're going to do this question 11, and the question that we skipped. And yeah, we're gonna do question 11 and question 10 specifically. Otherwise, thank you for watching. Don't forget to subscribe to our channel. Cheers.